First question to you. BrahMos or Tomahawk?
BrahMos.
You've been with the DRDO from right in the beginning.
I got an opportunity to work with Dr. Abdul Kalam, Lieutenant General Sundaram, Dr. Prahlada Ramarao, Dr. V.K. Saraswat, Dr. R.N. Agrawal, and Dr. Sivthanu Pillai.
It was mission accomplished on the first shot.
Pakistan Prime Minister Sharif, he's become our brand ambassador because he keeps saying everywhere that BrahMos has been fired upon us.
And what are the advantages?
This missile can engage refuelers, military transport aircrafts, enemy AWACS. India is capable of undertaking design, development and production of any kind of missile up to any range of any type. Everybody is possible target.
Hello and welcome to the Sandeep Unnithan Show, your weekly dose of defense, geopolitics and much, much more. Today I have with me Dr. Sudhir Mishra, former CEO and MD of BrahMos Aerospace. Dr. Mishra has spoken softly and carried a big BrahMos stick for almost a decade. Dr. Mishra, welcome to my show.
Thank you. Thanks a lot.
Always a pleasure to talk to you, Dr. Mishra. But first question to you. BrahMos or Tomahawk?
BrahMos. Always.
Why is the BrahMos better than the Tomahawk?
It's a history.
Right.
Actually, long back, US and Soviet Union, they started research on supersonic Ramjet,
Right.
developed the technology. And after spending few billions, Americans decided to drop because they were not able to see the result, whereas Soviet Union continued.
Right.
Present Russia. They continued and they could develop the engine by 1990, a working model. But it was still needing a lot of modifications to make it a missile worthy.
Right, right.
And
so the engine had all been developed by then.
Yeah, engine.
Right.
You see what happens, anything which flies in the air, whether it's an aircraft or missile or drone, they all are designed around engine, around the engine power available. And Russians continued because of their Soviet Union economy. And that's how you see that Americans are having a subsonic Tomahawk subsonic. And whereas subsonic Tomahawk means it's based on the turbofan engine technology. That's much easier, much simpler. And but it's a subsonic, less than the speed of sound. Whereas this BrahMos is 3 Mach. 3 Mach, it gives too many advantages.
Right. No, and the reason I asked you the BrahMos and Tomahawk question is that the Americans just recently fired 30 Tomahawks as part of Operation Midnight Hammer on Iran. We fired many BrahMos missiles against Pakistan during Op Sindoor. Right. So it's 2 neighboring countries who've been targeted with one with BrahMos and one with the Tomahawk. So the interesting part now is not a lot of people know that the Tomahawks actually came from a submarine, VLS tubes of a Ohio class converted to fire Tomahawks. Now you were part of that initial underwater version of the BrahMos. You were either already there in the BrahMos Corp or you were almost joining there. The test was when? 2013, March 2013?
Yeah. I joined as a CEO after that.
After that?
Yeah, after that.
But it's been 12 years since we tested the underwater version of the BrahMos. We still don't have the missile.
There are many reasons for it. You see, you have asked many questions.
Okay.
The first question you talked about is that Tomahawk has been fired at Iran.
Yes.
That's truth. That has been declared by US government. Whereas when it comes to the BrahMos, interestingly, Pakistan Prime Minister Sharif, he's become our brand ambassador because he keeps saying everywhere that BrahMos has been fired upon us. Government of India has never given any statement about firing of BrahMos in Pakistan. So let us accept the statement of Pakistan Prime Minister, that the BrahMos has been fired upon them. Now, why? Why not many more? And why not from the submarine?
Right.
You see, what happens? US is a world power, and they need to ensure security and protection of their interest globally. So they need to have a submarine which can fire hundreds of missiles on enemy at any given time at much shorter notice. Whereas our need is not like that. Our need is there to integrate the BrahMos with the submarine, but there are many reasons for it. You see, the first thing is we have been using kilo class Russian submarines.
We have about 7 kilo class.
Yeah. And then HTW, German submarines. And both have frozen design.
Right.
If you have to integrate BrahMos to a submarine, we need to integrate a kind of universal vertical launcher module in the submarine. So it's a vertical launch.
But you already done this work, right? You've done all of the research that would
No. What happens? Kilo class and HTW both can launch a missile from their torpedo tube.
Right.
Where the torpedo tube means it's about 533 millimeter of diameter.
Yes.
The BrahMos is more than 700. So it cannot fit in to be launched from the torpedo tube. One reason.
Right.
The second is kilo class and HTW cannot be modified.
Right.
So our Indian Navy said we will integrate it with the P-75.
Right.
Now, what happens? There are another you can say dimension to the whole thing.
Right.
That we are working with French, and MDL is manufacturing P-75.
The Scorpions. Yeah, they all delivered. All of them are delivered.
All of them are delivered. Right. So this was not fitting in there. So when we made this universal vertical launcher module, we discussed with the submarine designers. We discussed with Russian, German, and Spanish.
Right.
Navantia, HTW, and the Russian one. So all the three manufacturers have accepted that it can be fitted in.
Right.
They have accepted, and they made a presentation also to Indian Navy. Okay. So we decided that when we make a P-75 India, then we will be using all the Indian sensors, weapons, and AIP, Air Independent Propulsion, in our P-75 India, and we will integrate in that.
Right. So what does the BrahMos plug look like?
It's 8 submarine plug.
Okay, you mean 8 tubes?
No, single 8.
Right.
8,
one block with 8 missiles.
With 8 missiles.
Right. So that fits into the submarine. That can be put in as a block, and that kind of it's part of the submarine.
Yes.
Right.
So it can become. It's like a plug, you can say, module.
A module.
This module. So if you take a existing missile, you have to cut it in between.
Yeah.
Put the plug in between, and then you have to join these two portions to this plug. So what happens? It was difficult for the existing missiles to be modified like this.
Right.
So they said when we make our P-75 India, we will integrate.
But the P-75 India is nowhere on the
for
horizon.
the last 15-20 years.
20 years.
Many times RFI has been issued, but every time withdrawn. So I'm sure there must be some intelligent reasons to do that.
Right.
So we are waiting for P-75 India to happen. And when it happens, then the BrahMos would certainly be integrated with it.
Right. So, coming back to the underwater test that you were part of.
We did it with pontoon.
With a pontoon?
Yeah.
Right. And so what was the test like? Was it a success? How did the missile perform?
Pontoon, we launched it to simulate a submarine.
Right.
And you see, a underwater missile is having a kind of different technology. We have to understand that.
Right.
So what happens? Because you fire it under the water, so missile comes out. Then there is a sensor at the surface. It tells. It's a sensor which conveys that now your missile is out of the water.
Right.
And then the nozzle is ejected, and the missile becomes vertical.
Right.
The booster is fired. After some time, booster is ejected. It flips over because of the nozzle.
Right.
Yeah, you have seen in the front.
Yes, of course.
Front
and
cap.
it spins off in a way and like a bottle cap.
Yes.
And then it,
so that changes the direction and then it ejects out.
Right.
So it's a kind of casing, you can say casing of the missile.
It's a heavy thing. It's about a ton.
It's very heavy.
Yeah,
it's very about 800 kilogram.
Yeah, it's almost a ton.
It's a full of a lot of technology.
Yes.
A lot of solid fired motors are there. Motor means solid
which fire
propulsion.
off in a way that
there are about eight motors are there, and then it's a casing because you need to protect it against the water. So all that thing is there. Then once the sensor sends a signal that it is out, then missile goes up, it is ejected, and then booster starts. Take the missile to about 1.7.
So what distance did you test it to?
We have tested it to the full range of 290 kilometer.
In 2013?
Yes. And it has successfully performed, hit the target.
It hit the target?
What happens, targets are always not the physical ones. You have electronic targets.
Right.
So if the missile is able to go and hit the electronic target, you declare the mission successful.
Okay. So you did, it was mission accomplished on the first shot?
We accomplished the mission.
Right.
We demonstrated that this missile can be integrated with submarine.
Right.
And now we are waiting for a P-75 India where we can integrate the missile.
The P-75 India is at least 6 years away or 7 years.
It will take construction time will be 6 years.
Yes. So what about retrofitting it in an existing conventional submarine, like an existing Kilo which is going in for refit, or if you buy say new Kilo class submarines, refurbish them, can this plug that you've designed, which BrahMos Corporation has designed, can that be integrated into an existing conventional submarine?
You see, technically speaking, you can do anything.
Right.
But practically speaking, it's very difficult.
Right.
It will not be appropriate to do that.
Right.
It's a good idea to integrate it to a P-75 class of submarine.
Right.
That would be ideal thing.
An all-new construction.
All-new construction.
Right.
Because a lot of modifications are required in the submarine. And it will not be possible in the existing one.
Okay, because the existing one is designed around certain parameters.
Yeah, designed for some other weapons.
You would not want to tamper with the design.
You see, as a scientist, I can modify anything.
Yes.
But it would cost money and time. That doesn't justify modification of the existing submarine.
What about the existing strategic submarines? Like I'm just borrowing from the Ohio class example, where you have an existing ballistic missile submarine that's been retrofitted as a conventional missile carrier. Is it possible to do it on our existing strategic submarines?
You see, you can fire any missile from the torpedo tube.
Right.
But BrahMos can be fired only from the module. Vertical launcher module.
Yeah.
So that would call for modification in the submarine.
Right.
So it
or
can
the tubes, the existing BLS tubes of the submarine.
Yes. Right. So we can fit in 2 modules, 3 modules, 4 modules, make it like Ohio class submarine.
It is possible.
It's very much possible. Yeah. It would cost money. Right. It's very much possible. Why not? We can integrate maybe 2 modules, 3 modules, 4 modules, possible.
Per silo.
Yeah,
right.
per missile, we can do that. So, but it would, the missile, the submarine would become bigger and bigger.
Right.
So, and what happens, I think one more development has taken place, which has decided to go for, to not go for, the modification of the submarine. We have come out with air-launched BrahMos.
Right.
That can do the similar job.
Right, from the air.
Yeah, and you see, everything depends upon your area of interest.
Right.
So if the area of interest is 1,500, 2,000 kilometers, then you need submarine. And maybe 2,000, the air-launched BrahMos also can look after.
Right. So you're saying that it's just about ordnance on target. It doesn't matter whether it comes from a submarine or from an aircraft.
You're right.
Right. So, and what are the advantages, quickly, of a submarine launched BrahMos, which is now, I'm given to understand, the ranges are much in excess of what it was once, 290. It's gone up
you see,
that.
If you're using submarine, it's silent. You can go to any distance.
Right.
The target can be anywhere.
Yeah.
And the reaction time available for enemy would be much lesser.
Right.
Air launch, anything which flies in the air can be picked up by the radar, by satellite, and enemy can become alert. That's the difference.
So in the submarine launch, there's no alert.
There is very difficult for them because it's a sudden surprise.
It's a surprise.
You can come from anywhere. You can go anywhere, and you launch it when you're underwater. So you just launch it and vanish again.
And that is an advantage that a ship also does not have. A ship launched BrahMos also, because the ship is, you can see where the ship is.
Yes.
You can target it.
You can see it. Yeah. But submarine gives you that advantage of surprise.
Right.
Surprise and range. Because submarine can travel thousands and thousands of kilometers.
Right.
So almost everybody is on target. Everybody is possible target.
Right.
With aircraft, yes, but it is detected.
Right.
This is the difference.
Right. Interesting. So, quickly before I move on to the other topic that you've been very passionate about, the BrahMos, the variant of the BrahMos, is that how heavy is that plug that you designed in terms of how many tons would that plug or the module or the cassette with 8 missiles, would it be 100 tons or would it be...
No. It's much smaller.
Right.
It's difficult to tell you because what happens, we did it on the experiment basis.
Right.
The final design would be done when we get an order because it's quite a lot of work. Right. And when we do the design, we can choose the materials depending upon the weight. And the submarines are, they're very big. There are thousands and thousands ton of weight.
Yeah.
So 100, 200 kilograms.
It doesn't matter.
It doesn't matter. Makes no difference.
Right. Yeah, and I'm fully aware of the fact that you've been with the DRDL from right in the beginning, from the 90s.
I joined DRDO in 1984. 84 at Defense Research and Development Lab, Hyderabad.
Right. And you had a chance to work with all the great DRDO scientists who have come out from DRDL. Dr. Kalam, there's Dr. Prahlada, there's Dr. Saraswat. I think you've practically worked with all of our great missile centers, and you're one yourself.
Sandeep, I am really very lucky that I got an opportunity to work with Dr. Abdul Kalam, Lieutenant General Sundaram, Dr. Prahlada Ramarao, Dr. V.K. Saraswat, Dr. R.N. Agrawal,
right.
Agni Fame.
The
Agni Fame.
Yeah.
And Dr. Sirthanu Pillai,
yes,
the giant of a scientist,
right.
missile scientist, who has worked in rocketry of ISRO and DRDO. So, in fact, BrahMos has been conceptualized by Dr. Abdul Kalam and Dr. Pillai.
Right.
Together.
Right.
So I got an opportunity to work with Dr. Pillai for a very long time. And of course, later on, whosoever was contemporary, very renowned scientist.
Right.
So I was really very lucky to work and learn a lot from these people.
Right. Absolutely. So, and Dr. Mishra, there's that one project that you were very close to, the variant of the BrahMos that we haven't seen yet. We've only heard about it. And of course, I spoke to you about it some time ago. It's the air-launched, air-to-air, very long-range air-to-air BrahMos missile. Tell us a bit more about that. Sounds like a very enigmatic, interesting missile.
A few years back, about 7 years back, we considered that the BrahMos, let's call it the BrahMos Prime, the main one, original one, we can make it a air-to-air version. We did study, and we found that yes, missile can engage refuelers, then military transport aircrafts, then enemy AWACS.
Right. So-called HVTs,
yes.
high-value targets.
Yeah, high-value target. You see, there is a very simple thumb rule. If your missile can fly almost, you can say, 2.5, 3 times the speed of the target, then you can engage it. Okay. So the BrahMos was able to engage. I'm not talking about the speed. Let me talk about the G. Okay. Right. So 3 times G. So if it can move, then it can engage any target. It's a thumb rule. So BrahMos can do that. But it needed data link. long range data link. At that time, we didn't have Akash Tir or uh, Indian Air Force air command and control system in place.
IACCS2. Yeah.
Yes, we didn't have.
Your data link between the missile and
the launching
aircraft,
platform.
the launch platform, right?
Yes. So that data link is required because if you are engaging a flying target, then we need to have data link. So at that time, it was not available. Now we have it. So but it takes time also. That it will take about 3-4 years. You need to modify seeker.
Right.
You need to reduce the weight of the missile. Then
the missile in its present configuration won't work.
It can be used, but minor software modifications are certainly required.
And what range would this air-to-air BrahMos have?
You see, what happens when you launch a missile from aircraft, you derive the advantage of momentum of the platform.
Right.
So that gives you much longer range, what a normal missile can give. So BrahMos launch was also like that. It's difficult to give you the number, but I can say it was able to give us considerable range, very long range.
That would be in excess of 400 kilometers, 500 kilometers, or even more.
You see, I do not have access. Now I'm retired.
Right.
So I don't have access to the right numbers. Right. So I would not like to give you the misleading numbers.
Right.
But as a scientist, I can certainly tell you that yes, it would be much longer than the normal missile.
So it range. Is it much longer than the longest ranged air-to-air missile that is there in service anywhere in the world?
Scientifically speaking, yes, it is possible.
Right. But what are the kind of modifications you have in mind? One was, of course, the data link, which you said is already...
One is the data link. Then second, seeker, because right now it's a X-band seeker.
Right.
To engage slow-moving ships.
Right.
When it is moving very fast, then you need different kind of seekers.
Right. So has that seeker been developed?
No. You see, what happens, we cannot do the research in the vacuum.
Right.
It's a applied research.
You need
order. I will not say order. We need some kind of requirement, that firm requirement from the user.
The user has not given you this kind
of
requirement.
They said they want it, but it was not feasible engineering wise at that time.
Right. At that time, you're talking of a decade ago.
No. It's about 5 years.
5 years back. But you see the requirement for a big missile of this kind, a BrahMos category.
You see, I don't think it would be required now.
Right.
It should not be required, because now there are, you see, one interesting thing.
The Astra 2.
Yes, you are very much interested to know.
Yeah.
So let me tell you that, let me tell you and your audience that India is capable of undertaking design, development and production of any kind of missile up to any range of any type.
Right.
We have developed that capability in the last 40-45 years. We have that capability.
Air to air.
Anything.
Air to ground.
Anything.
Ground to air.
Any tactical or any strategic missile India can develop.
Right.
We have skill. We have skill, knowledge, equipment, materials and wish. So anything is possible. We can do that. We have developed this capability. So whenever you say that, can we do this? Can we do that? Yes, we can do anything. But the user has to say that this is my requirement. And the government has to give the funding.
All right.
So these two have to match.
Yes. Right.
Otherwise, DRDO is very capable.
Right.
When it comes to the missile technology. We're very capable organization.
And you've shown that with the strategic missiles. I think we have completely developed all of them on our own, the DRDO.
Yes, you're right.
And you were part of those, as director missiles.
I have
part of some very interesting...
I have been part of the missile complex for the last 40 years.
40 years.
Yeah.
4 decades.
4 decades of my life.
Right. You know, coming back to the BrahMos, Dr. Mishra, the Ramjet engine, which is really the heart of the BrahMos, which is what powers the BrahMos to 3 times the speed of sound. You know, why haven't we indigenized that Ramjet engine? Why are we still dependent on Russia for the engine? We seem to be dependent on every country for every requirement for an engine. this is something that we should have developed by ourselves?
It's very interesting question, and answer is also very interesting.
Right.
There are 2-3 reasons. The first is, let me tell you that government has given full support. Russians also have given us offer of transfer of technology.
Yeah.
When offer is given for TOT, you see the BrahMos is not a TOT project.
Right.
That it's a transfer of technology from Russia to India. No. The BrahMos Aerospace has always been a joint research and development project. It was, in the very beginning we decided that some of the technologies will come from Russia.
Right.
And rest of the technologies would be developed in India. And we would be joining these two technologies in BrahMos Aerospace and in DRDO.
Right.
So when the offer came for TOT, we said we never thought about TOT.
Right.
But at the same time, DRDO has also undertaken a project to develop the Ramjet engines.
Right. Right.
And they also have engine not matching to this requirement, not matching to the DRDO requirement.
So,
smaller engine they have developed.
So is the, you mean the Russians have developed
like
a smaller
Star.
engine?
No, India. DRDO
India has
has
developed a smaller Ramjet.
You know the Star missile?
Yes, yes, of course.
Star missile uses the Ramjet engine. Okay, this is one.
Right.
The liquid Ramjet engine it uses. The second is we have tested about 1.5 months back.
Yes.
There was a public statement by DRDO that we have tested a scramjet engine.
Yes.
Supersonic Ramjet engine.
2000 seconds.
1000 seconds. Yes. It means we can make a missile, hypersonic missile, which can fly for 1000 seconds.
Which is about how many minutes is that?
Please calculate.
8 minutes?
1000 missiles, yes. 8 minutes. So 8 minutes, and if it is
the entire flight time of a...
It's about 7-8 Mach.
Yeah.
So you can calculate the
it's
full
the entire
range.
range of a missile.
You see what happens the moment you talk about scramjet engine,
yeah,
the whole range would be supersonic, hypersonic.
Hypersonic.
It will be hypersonic.
Right. So you're saying that we don't need the Ramjet technology
as of now, yes,
from the Russians because we've developed our own scramjet technology.
Second reason. The second reason is BrahMos is a joint venture.
Right.
And if we make the missile 100% in India, then what would be the interest of Russians? So there should be some sustainable interest on the Russian side also.
Right.
So we decided, okay, you keep on sending us the engine. Rest of the things we will manufacture here,
right,
and give it to the users. And there is no shortage. There is no. We have never felt the requirement to do the. We were not missing out on the supply of the engine.
Right.
So let's sustain their interest in the project, and commercially and strategically.
Yes.
So we decided we will develop our own engine here. Till then, keep on taking the engine, but we can. It's a very complex business decision.
So, has any BrahMos technology, Ramjet technology, been used in any other programs, or is this a standalone? Like BrahMos is a standalone, and our indigenous Ramjet is a standalone.
In BrahMos, as I mentioned to you, it's a joint research and development.
Right.
So DRDO is responsible for developing the Indian side of the technology.
Right.
So whatever has been developed by DRDO for Indian side,
right,
that we can use anywhere because it's our copyright.
Right.
It's our patented technology. But whatever has been supplied by the Russians,
yes,
so they own the patent. Right. And they have supplied it in the ready-to-assemble condition.
Right.
So it's not possible to use the Russian technology in our Indian missile systems.
Right.
Of course, if Indian missile program need Russian technology, they can directly talk. Why to bring BrahMos into the picture? BrahMos is a standalone company. Right. BrahMos Aerospace.
BrahMos Aerospace.
Yeah, and DRDO is developing the technology for Indian side of the share.
So what about the BrahMos NG? We've been hearing about it for a long time. BrahMos NG, the BrahMos Mark II. Are they the same or they're different missiles?
BrahMos NG is a much smaller version of BrahMos missile. The idea to give it name as a BrahMos is it follows the same principle of operations.
Right.
Both are liquid ramjet. The engine is miniaturized, and you see, the BrahMos missile has been developed in 1980s and 90s,
Right.
whereas the NG is being developed in 2020s and 30s. So this missile would be using state of the art, latest technology.
Right.
When it comes to the materials, manufacturing processes, assembly, so it will be just state of the art. And right from the beginning, we are designing the missile for usage by all the services: Army, Navy, Air Force. And so all the versions would be developed simultaneously.
Right.
I feel because it's much smaller and using the latest technologies, it will be much cheaper also.
Right.
So we can have it in plenty. And we can use, when it comes to the platform, we can package many more. You remember sometime back you talked about Ohio class of
Yes,
submarine,
right?
Where more than 100
more than 100 Tomahawks on
more
one
than 100
Ohio
Tomahawk
class.
are integrated. So when it comes to the NG, possibly your dream of integrating hundreds of the BrahMos on submarine would become reality.
Right.
Yes.
Oh, it's
possible.
What a bright BrahMos future we are headed to, Dr. Mishra. India's dream of being a missile power, Dr. Abdul Kalam's dream, in fact, is close to being realized. And what a pleasure and an honor it's been to talk to you, someone who's been part of that 4-decade-long journey, Dr. Mishra. Thank you very much for your time and for your thoughts.
Thanks, Sandeep. Thank you.